So this video is going to be for people who are either really struggling to get started with CFD or just can't find resources on the internet that explain CFD clearly enough. And so I'm going to be using this super basic profile to walk you through the steps of how a CFD run is conducted. And I'd encourage you to make this yourself in SolidWorks and then follow along with the CFD run. That way you start to get the hang of what CFD is really like. The dimensions on this aren't super important, but the major thing is that the origin, as you can see, is in the center of that rectangle. That'll be important because we want to take advantage of the global coordinate system in ANSYS, and thinking about that while we're designing in SolidWorks just makes our life easier down the road. Once you're done creating that body, save it as a .iges file and open up Workbench. Look at your toolbox on the left and find Fluid Flow CFX and then drag that into your Workbench. It'll give you the option to rename it so that you can identify it better. We don't really need to do that for this because we're only doing one project inside Workbench. But like for my final iterations Workbench file, I had, something like 25 different projects within that. And if I hadn't been in the habit of naming those files, it would have been a pain in the butt to get to each of them individually. So I'm going to go ahead and name this one something. Next thing is to import your new geometry. So right click on geometry, go to import new geometry, or whatever the first drop-down menu is, and then click browse. Once you find the .iges file that you just saved, that blue question mark next to geometry should turn into a green check mark. Next, double click on geometry and this window will open up. Once you see this window, go ahead and double check that you only have one body inside this file, because if you have surface bodies or multiple bodies, it could create problems with meshing and solving later on. And so resolving that has to be done in SolidWorks before you ever get to ANSYS. Once you do that, go to the Tools menu and select Enclosure. For now, we're just going to leave all the settings as they are. Everything should be set to 1 meter. But we are going to change our number of planes from 0 to 1. And you'll see that symmetry plane 1 turns yellow. And so go ahead and click on that. Click on your XY plane, or whichever plane runs down the middle of the body, and click Apply. Once you've done this, go ahead and click Generate, and your screen should look like this. Our next step is to go to Create and click Boolean. Once you do this, go to Operation and change Unite to Subtract. Click on Target Body, click on the enclosure, and click Apply. Our tool body is going to be the thing we designed in SolidWorks. So go to Tool Bodies, but since we can't actually get to the tool body without going through the enclosure, you're going to want to click on this instead. Once you do this, click Generate, and that's all you need to do for the geometry step. Next, we'll go into Meshing. So when you get into Meshing, click on the Mesh menu, and then go down to Size Position and Relevance Center. Change your size position to proximity and curvature, and change your relevance center to medium or to fine. Once you've done this, click Generate Mesh, and you should see a screen similar to mine. If your mesh fails, it'll show up yellow or red, but since this design is so simple, I doubt that any of you will have problems with meshing this. So the next thing is to set our inlet and outlet boundary. And to do this, left click on a face to select it, right click, choose Create Named Selection, and name this one Outlet. You're also going to do this with the 4 side faces, which you'll name Symmetry, and the front face, which you'll name Inlet. Once you're done with all of this, click Update, and when ANSYS is finished updating, just exit out of Mesh. The next thing we'll do is we'll go into Setup, and under Simulation, Flow Analysis 1, you're going to see Default Domain and Default Domain Default. Right click on Default Domain, go to Insert, and click Boundary. For this first one, we'll do Inlet, and as you can see, when we name it Inlet, the computer already knows that this is an inlet boundary type, and it's located at the inlet face. Under the Boundary Details tab, set the normal speed to 50 meters per second, and then click OK. You're going to repeat these steps 2 more times, first naming it Symmetry, and you'll notice that there's no boundary details for Symmetry, because Symmetry sort of defines itself, and then 1 more time for Outlet. Under the Boundary Details tab of Outlet, set the relative pressure to 0 pascals, and then click OK. The last thing we're going to do in our setup section of ANSYS is, once again, right-click on Default Domain, select Details, and under the Fluid Models tab, you want to change K epsilon to Shear Stress Transport. If it's not in the drop-down menu, you can click on the little ellipsis next to K epsilon and switch it to Shear Stress Transport like that. Click OK, and then click OK again to exit out of this menu. Click on the Save button in the upper left, and once it's finished saving, exit out. Next, you'll double-click on Solution, and when this Define Run window opens up, switch your run mode from Serial to Platform MPI Local Parallel, and set your number of partitions equal to the number of logical processors you have on your computer. If you don't know how many logical processors you have, open up Task Manager and count the number of graphs there are in the CPU Performance tab. I have 4, so I'm going to change my number of partitions to 4. Once you set your number of partitions, click Start Run and wait. Once everything's done, this screen will pop up. Click OK and then exit out. The last thing we want to do is review our actual results. So double click on the Results tab and then wait for this screen to pop up. In the upper left, you can check the box next to Default Domain Default and it'll turn your body a solid blue color. That way it's easier to see. So once you've done that, you can create planes to draw streamlines from. And so what I did is I went to location, plane, and I'm creating a 3 points plane. Once you've done this, you can click OK, and then right click on plane 1 and click on insert streamline. If you want, you can mess with all the different streamline settings, but for now I'm just going to leave it set to its default, and you should see this pop up. Once you've gotten to this point, you're done. You can use this to run CFD on pretty much any simple aerodynamic device, but you should be careful when running CFD on stuff like louvers and end plates, because there's a lot of more complicated meshing parameters that I didn't go into in this video. We'll go into them at a later time, but for now I just want you guys to start getting comfortable and playing with CFD. That way when we get into the more advanced stuff, you aren't overwhelmed or caught off guard. Anyway, I hope you guys found this useful, and if there's anything you have questions about, don't hesitate to ask me or James.